We've all seen AI get incredibly good at understanding language, right? But what about sight? Well, today we're looking at a huge breakthrough that's totally changing how computers see. Some are even calling it the Chat GPT for pixels, and it's giving AI a brand new way to understand our visual world. Okay, so imagine you could take any photo, click on literally anything in it, like this cat right here, and just perfectly lift it out from the background. I'm not talking about a rough, sloppy outline, but a perfect pixel for pixel selection. Now, what if you could do that for anything, in any image with just one click? You know, that idea of creating a universal cutout tool, or what researchers call a general segmentation model, has been one of the biggest goals in computer vision for a long, long time. And honestly, it always seemed just a little bit out of reach. Until now. And this is it. This is the breakthrough. It comes from Meta AI, and it's called the Segment Anything Model, or SAM for short. See, instead of training an AI for just one super specific visual task, SAM is built to understand the basic concept of what an object even is. The secret sauce here is that it's a foundation model. Now, if you've ever played around with something like ChatGPT, you already get this. It's a massive AI, trained on a gigantic, super general dataset that you can then prompt to do all sorts of different things. SAM is taking that exact same idea and applying it to the world of images. So here's the crucial difference. With a language model, you give it a text prompt. You type something in. With SAM, you give it a visual prompt. You don't need to type a fluffy cat sitting on a chair. You just click on the cat. That single click is the prompt, and the AI's response is a perfect digital cutout. So how in the world is it so fast? Well, it's this really clever three-part system. First, a super powerful eye scans the whole image one time, soaking in all the details. Then, the instant you click, a lightning-fast brain figures out what you're pointing at. And finally, a super nimble hand draws that perfect outline, all in about 50 milliseconds. That's literally faster than you can blink. Okay, but this is where it gets really, really clever. What happens if you click on a spot that could mean more than one thing, like, say, a button on a jacket? Do you want just the button, the whole jacket, or maybe the person wearing it? And this shows the solution perfectly. Instead of just guessing and probably getting it wrong, SAM is designed to be ambiguity aware. So if you click one point on these scissors, it knows you might mean the handle, or maybe just one of the blades, or maybe you want the whole thing. So it just gives you all three valid options and lets you pick. It's brilliant. So a model this powerful needs a mind-boggling amount of training data. But where do you even get a billion perfect image cutouts? They aren't just floating around the internet. This created a classic chicken and egg problem, and solving it required a seriously clever solution. They built what they called a data engine, basically a three-stage feedback loop. In stage one, they had human annotators use an early, kind of clunky version of SAM to help them label images faster. As the model got better from that data, they moved to stage two, where SAM would automatically handle the easy objects and the humans just focused on the tricky stuff. This cycle kept going until finally they hit stage three. The model became so powerful, it could generate the entire massive dataset, all by itself. And the result of that process is a dataset on a scale that's just hard to comprehend. It's called SA1B, and it has over 1.1 billion, that's billion with a B, segmentation masks. It's just a staggering number. If you're trying to picture what a billion masks actually lets an AI do, just look at this image. Every single one of these locks, no matter how tiny or crowded it is, has been identified as its own separate object. The level of detail here is just on another level. And just to put that number in perspective, the SA1B dataset has over 400 times more masks than the next biggest dataset out there. This isn't just a small step up, it's a monumental leap forward for the entire field of computer vision. So, what's the big payoff for all this work? Why build something on such an insane scale? Well, the answer is something incredible called zero-shot performance. Zero-shot basically means the model can accurately identify and segment objects and scenes it was never explicitly trained on. It can generalize its knowledge to brand new, totally unfamiliar things right out of the box with no extra training. It's like it has learned the concept of what an object is. Let's just watch it work. Here it is, perfectly breaking down all the tiny, intricate details of a Japanese gate, a really complex scene with tons of overlapping parts. Now look at this, a totally different kind of image. It identifies the horse, the saddle, the grass, the trees.
It just switches from man-made structures to natural objects without missing a beat. It even gets the context. It doesn't just see the airplane, it sees the runway it's on and the trees way back there as totally separate things. And here's the final boss, a chaotic, crowded, messy scene. I mean, look at this. Every single player, the hoop, the backboard, it's even identifying individual people in the stands. That is the power of zero-shot performance. So what does the tool this powerful actually mean for the future? Because believe me, this goes way, way beyond just editing your photos. The possibilities are huge. Yeah, of course, creative tools for photo and video editing are going to get amazing. But think bigger. Think scientific analysis, where it could spot individual cells on a microscope slide. Or augmented reality, where digital stuff can finally interact with the real world in a believable way. And maybe the biggest one of all, robotics, helping machines perceive and understand the physical world around them, kind of like we do. And that's really the heart of it all. The Segment Anything model isn't just a new feature for Photoshop. It's a fundamental step forward. It's about going from specialized AIs that can do one thing pretty well to foundational AIs that have a much more general, almost human-like understanding of what they're looking at. This whole project is being released openly for anyone to build on, which leads to a really fascinating final question. We've kind of moved past asking if an AI can see the world in detail. Now the only question left is, what are we going to ask it to see next?